So today you're learning how to simplify radicals. Today you're learning about square roots, and then tomorrow you're going to learn about cube roots. And this is kind of hard and confusing, but just be sure to stick with me and just let me know if you need help with anything. So for the square roots, so if you take the square root of a number that's not a perfect square, that's what you can write first here. So perfect square. You can take the square root of the perfect square factor and then leave your other factor in radical form. And then, so the way I'm going to show you how to do these today, instead of figuring out which perfect square factors divide into the number under your radical sign, we're going to write the prime factorization of our numbers here, because doing it this way, you can do the same thing tomorrow instead of just memorizing the perfect squares. So, we're going to follow these steps here, step 1 and step 2. So you're going to write out the prime factorization of whatever numbers under your radical here, the square root symbol, and then you'll do the next step. So I'm going to list out some primes first. Okay, so I'm going to make a list of prime numbers at the top, just so you have this to refer to make it easier. Because these primes will help you to work these out here. So remember, prime numbers, that means the only thing that divides evenly into the number is 1 in itself. So the smallest prime will be 2, because the only thing that divides evenly into 2 would be 1 and 2. So 2 would be your first prime, and then your next prime would be 3, 4 wouldn't, 5 would be your next one, because the only factors are 1 and 5. And then 7 will be your next one. 8 wouldn't be, 9 wouldn't be, because 9 would be 3 and 3 also. 10 wouldn't be, so 11 would be your next one after 7. And then 12 wouldn't be, 13 would be prime because you only have 1 and 3 that divides evenly. And then this will continue on. I'm just not going to write the whole list there. So to start, we're going to write the prime factorization of 52. So for these, I would divide by 2 until you can't anymore, as long as your number is divisible by 2. I just think that's easiest to start with here because it's easy to see if it's divisible by 2, because if it's even, it would be there. And 52 is even. If it's not even, you can start by dividing by 3 to see if 3 will go into it. So we're going to write the prime factorization of the 52 to start then. So like I said, so you're going to divide 52 by 2 first. So you can write a 2 first inside here, because you'll take out as many 2's as you can. If you divide 52 by 2, then you get 26. And you can take another 2 out of the 26. So I'm going to write times 2. So you are down to 26, and then once you take a 2 out of the 26, then you'll get 13. And 13 is a prime, which means you'll write it under here. Okay, so that's what you have. And then like it says here, the next thing you'll take out in groups of 2. So for every pair of numbers, you'll take one of them out. So because you have a pair of 2's here, you'll cross off these inside here. So for every pair inside, you'll bring one outside. So then your final answer here, then you can clean this up and write the best way possible. So your answer would be 2 square root of 13 then. And the reason you can do that is because 2 times 2, I'm going to write this another way, is 4. And then it's because the square root of 4 would be 2. So that's why you can take this out here. I just think it's easiest to write your prime factorization there instead of the perfect squares like the 4 there. Okay, So for the next one here, so like I said, so we're gonna write the prime factorization. So I would divide by 2 until you can't anymore. And if 2 doesn't divide evenly into the number, if it's not even, then you can start by dividing by 3 to see if that would be divisible. So for 24, this is even. So you can take a 2 out to start. So if you divide 24 by 2, then you're down to 12. And 12 is still even, so you can take another 2 out of 12. So you can write another 2. So 24 divided by 2 gave you 12. 12 divided by 2 will give you 6. You're down to 6 now, which you can take another 2 out of your 6. You can do times 2 again. And then, so when you divide the 6 by 2, then you'll get 3. And 3 is prime. That's why I listed it here. If it wasn't prime, you would figure out whatever prime divides evenly into it. And then before you do your next step from here, you can multiply your prime numbers under your radical to make sure you get the 24. So if you multiply them together, 2 times 2 would be 4, times another 2 would be 8, and then times 3 would give you the 24, just to make sure you didn't miss a prime factor here. And remember, for every pair that matches here, you'll take one of them out. So for this pair of 2's here, you can cross these out here, and then you'll take 1, 2 out. So then you should just clean this up here. So you have the 2 on the outside, and then you have the square root of, and then you'll multiply whatever you have left inside. So be 2 squared is 6 for that one then. And then for the next one, so for 60, so this is even, so I'll divide by 2 until you can't anymore. Because since it's even, you could at least take a 2 out. So if you divide 60 by 2, so then you're down to 30. And you can take another 2 out of the 30. So if you divide 30 by 2, then you're down to 15. So for 15, you can't take another 2 out, but your next prime's 3. So if you divide 15 by 3, because 3 will go into the 15 evenly. So if you divide the 15 by 3, you'll get 5, which is also prime. So you can have both of those. And like the other one here, you can multiply these together and then make sure you get the 60 so you didn't miss anything. Because 2 times 2 would be 4, 4 times 3 would be 12, and then 12 times 5 would be 60. So we didn't miss anything here. Remember, for every pair of numbers that matches, you'll take one of them out. So your 2's match here. So you can cross these out, and then you'll put 1, 2 outside. So this would be 2, and then the square root of, and then remember you're multiplying what's inside there. So 2 squared is 15 for that one then. And then for number 3 here, so you can leave the 4 outside for now. And then, so the 98, so you'll write out the prime factorization of 98 here. And so it's even, so I'd take a 2 out first for this one, because 2 will go into the 98. So if you divide 98 by 2, so if you divide the 98 by 2, then you'll get 49. And so 49 is odd. So 2, you can't take another 2 out. 3 is the next prime, which won't go into 49. Then 5 is the next one after that, and then 7. So you can divide 49 by 7, which would then be 7. So pretty much you'll have 1, 2, and then 2 7s. Because when you divide the 49 by 7, then you'll get 7. And then you can always multiply these together inside and make sure you get the 98 there, and you should. So for every pair you have, you'll take one of them out. So your 7s match here. So you can cross these out, and then you'll take one of the 7s outside. And then you'll multiply by the 4 that was there already. And then you can just clean this up here. So you'll multiply these, like I said, because the 4 is there already, and they brought the 7 to be 28, and then square root of 2 for this one then. And then for the next one here, so you can write out the prime factorization of the 162. This is even, so you know for sure you can take a 2 out. So you can divide the 168 by 2 first. So if you divide it by 2, then you get 81. So 81 you can't take another 2 out of 81 because it's not even. So if you look up here, your next perfect square after the 2 would be 3. So you can divide the 81 by 3 to see if it goes in evenly. And if you do divide the 81 by 3, it goes in evenly and you'll get 27. So you put the 3 down because it did divide evenly into the 81. So now you're down to 27, and then another 3 will go into your 27. So you can divide 27 by 3 again, which would then be 9. And then, so 9, you can take another 3 out of your 9. So you can write your another 3 here. And then when you take the 3 out of 9, then you're left with a 3, which is also prime. So there'll be 4 3s here. And you can always multiply these together to make sure you do get the 162 there. Just since it's kind of long, to make sure you didn't miss anything. And then remember, for every pair of numbers, you'll bring one of them outside. So you can't take the 2 out, but for the 3s, okay, so you can take one of the 3s out here from this first set, and then you can take another 3 out from your second set, and then you'll multiply whatever you bring out. So this would be 9 squared at 2 for this one then. Okay, and then for the next side here, okay, I'm going to do number 7 first and then go back to do those two. So for number 7, so you can write out the prime factorization of the 8 here first. So I would divide by 2 until you can't anymore here, because 8's even, so 2 would divide evenly into it. So if you divide the 8 by 2, then you get 4. And you can take another 2 out of the 4 then. And then when you do take the 2 out of 4, then you're down to 2. So you'll have 3 2's there. And then for your variables here, I'm going to write these out the long way. So pretty much you have like 5 x's. I'm just going to stick these all beside each other instead of doing times side or whatever. And then you have your y's. So for your numbers here, so remember, for every pair, you can take one of them out. So for these 2's here, you can take one of your 2's out. And then for your variables, I was going to write with a different color so you can see. So for the x's, you have a pair of x's here, so you can cross these out and then bring one of them outside. And then you can cross out another set. You'll have one of these x's left inside. And then for the y's, you can do the same thing here. So you can bring this set out. And then your other set here. And then you can write this the best way here. So you have your 2 outside, and then this is x times x, so that'd be x squared outside then. And then the same thing with the y's, because you have y times y. So that'd be y squared. And then the only thing you have left inside, you have one of these 2's and then an x. So if you'll notice here, so pretty much when you have the variable there, you'll want to be able to divide your x in it by 2. If not, you can rewrite it. Because like this one here, if you divide your x in it by 2, you get y squared, because y squared would give you y to the 4th. This one here, you'd have to rewrite it though. So I'm going to do this one up here then. So you'll write out the prime factorization the 21st here. So it's even, so you'll want to divide by 2 until you can't anymore. So you can divide by 2 first, which would then take you down to 10, and you can take another 2 out of your 10. And if you take a 2 out of the 10, then you're down to 5, which is prime. So you can list that there. And then you wanna, so I'll put the x to the 36 power here. Because I'm not gonna write out 36 x's here. Plus I'll tell you a different way you can do the variables. It'll take less work. And then remember, for every pair of numbers, you'll bring one of them out. So the 5 has to stay, but your 2's can come out here. So then you can multiply by the 6 here. And then for your variable here, so as long as you can divide the x in it by 2, this will be your answer. Although sometimes you may have to rewrite it. If you can't divide by 2, if you have like an odd x in it, like the 15 here, you'd have to rewrite it. This one here, you can divide the 36 by 2, so pretty much you're going to cross this out, and then you'll have x. If you divide 36 by 2, you get 18. So this will be x to the 18th here. The reason you can do this is because if you have it like, if you square this, you will get x to the 36. That's why you can just divide the x in it by 2 pretty much there. This will be x to the 18th out here then. And then you can write this the best way. So you can multiply the 2 and the 6. So this would be 12 x to the 18th, and then the square root of 5 is the only thing you have left there inside. And then for the next one here, for the 49, so you want to write out the prime factorization of this to start then. So it's not even. So you can't take a 2 out first. And then 3 wouldn't go into the 49, 5 wouldn't, so 7. So you can divide the 49 by 7. So if you divide by 7, then you'll get 7. So you'll just have the 2 7s here. And then you'll want to be able to divide your x in it by 2, and you can. So you don't have to rewrite your variable there, it can just stay. And then remember, for the numbers, so for every pair, you'll bring one of them out. So these 7s can come out because you had a pair of them there. And then you'll divide the x in it by 2. So you can do 2 divided by 1. So this will just give you like x to the first out here, and then, or just x. And you don't have anything left inside your square root symbol here, your radical, so your answer is just a 7x, just because it's a perfect square there. Because the square root of 49 is 7, and the square root of x squared is just the x. This will just be 7x there. And you won't write anything under the radical since you didn't have anything left there. Okay, so for number 8, so you're gonna, so this 3 is still outside, and then you can write out the prime factorization of the 100, sorry, for the 125. So it's not even, so you can't take a 2 out first. You can try dividing 125 by 3, but it won't go in evenly. And then your next prime after 3 would be 5. So 125 will go into 125. So you put your 5 here, and then if you do divide by 5, then it's down to 25, which you can take another 5 out of 25. And if you divide the 25 by 5, then you have another 5. So really, hold on, you'll have 3 5s here. And you can check to make sure that does give you the 125, that we didn't miss anything. And then for the variables, so you'll want to be able to divide the x in it by 2. This x to the 15th, you can't. What you're going to do, you're going to rewrite it as the next smaller power that you can divide by 2. So the next smallest number from 15 that you would divide by 2 would be 14. So you're going to rewrite this. So this will be x to the 14th, and then another x here. Because together, this would be x to the 15th. It's just that this x to the 14th, you'll be able to take out because you can divide the x in it by 2. And this y, it's like y to the first. You can't rewrite it all. There's no way you can divide by 2. It'll just stay in here. You can just leave it like this to start. And then remember, for every pair of numbers, you'll bring one of them out. So for the 5s, you can bring a set of 5s out here that you can multiply by the 3 there. And that 5 will stay in. And then now you can divide the exponents by 2. So you can divide the 14 by 2. So you'll have x to the 7th here then. Because if you square x to the 7th, you get x to the 14th. And then these have to stay in there because you can't divide the exponents by 2 because you have 1 and 1. So then you can just clean this up. So you'll have 15x to the 7th outside the square root. And inside you'll have 5xy. And then for your next one here, so for number 9, so this is not even, so you can't take a 2 out first. So I divide by 3 to see if 3 goes evenly into your 147. So if you divide the 147, so 3 will go in evenly. So you can write a 3 first then. So if you divide the 147 by 3, then you get 49. And you can't take the prime that goes into 49 would be 7 then. And if you divide 49 by 7, then you'll have 7. Since 49 is a perfect square. And then you can multiply those and make sure you get the 147. So we didn't miss anything if you want to check it there. And then remember, you want to be able to divide your exponents by 2 here. So x to the 7th, so you can't divide that by 2, so you can rewrite it as the next smaller power. So the next smallest power below the 7, so it'd be x to the 6th then. So this would be x to the 6th, and then you'll have another x beside it. So that'd be x to the 7th together. We're just writing out like this. And then the y to the 6th, you can divide the exponent by 2, so that can stay for now. You don't have to rewrite it at all. And then, so remember, for every pair of numbers, you can bring 1 out. So these 7, so you can take 1 out here. And then for your variables, you can divide the exponents by 2 here. So you can divide the 6 by the 2 for the x's here. So when this comes out, you'll have x to the 3rd. Because that was a perfect square there. And then you can divide the 6 by the 2 for the x and the y. This x will have to stay there. So this can come out then. So you have y to the 3rd then. So these will be outside. And then you'll have the square root of 3x is all you have inside there. I'm just going to move this aside here. Okay, so this is y to the 3rd. And then for the last one here, so you can write out the prime factorization, the 80 first here. So it's even. So I would divide by 2 until you can't divide the 80 by 2 anymore. So if you divide 80 by 2, then you get 40, which you can take another 2 out of 40 because that's still even. So you divide the 40 by 2, which would then be 20. So now you're down to 20, and you take another 2 out of your 20. And then when you take the 2 out of the 20, then you're down to 10. And you can take another 2 out of 10, which will then be 5. And then 5 is also prime, so you can list it here. And then for the variables, you want to be able to divide the exponents by 2. So this x to the 5th, you can't divide the exponent by 2, so you can rewrite it as an x smaller power. So that'll be x to the 4th, and then you'll have another x beside it, because that's the same thing as x to the 5th. And then your y to the 6th, you can divide the exponent by 2, so it can just stay like it is for now. And then for every pair of numbers, you'll bring one of them out. So for the 2's here, so you can cross these 2's out and bring 1, 2. I'm going to write down here where there's okay. So you'll bring 1, 2 out there then, and then you'll bring another 2 out for that set. And then for the variables, you can divide your exponents by 2 here. So you can divide the exponent by 2 on the x's. So 4 divided by 2, so you'll have x squared there then. And then this x will have to stay because you don't have enough to come out. And then you can divide the x and out by 2 for the y. So you'll have y to the third outside. So that stuff's outside. And then you can just multiply these outside and just look better. Okay, so 4x squared y to the third. And then you'll have the square root of 5x here. So that'll be your answer then. So, so I'm linking to strands in IXL for you to work on. So once you have a score of 90 for each of the two, you should like let me know. That way I can look at your score so I know how you did on it. So that's how you'll be getting credit for the stuff for today is so once you do both of them, you can just tell me and I'll check on IXL and make sure you do have a score of at least 90 or above. Just know you'll have to log into IXL first by clicking on like the link in Google Classroom, like not the post from today. It's under like the Classwork tab and then the topics first. So you have to log into IXL under the Augusta County one first, and then you'll have to click on the link that I posted. Just let me know once you have a score of 90 or above. That way I can check it for you. And then just let me know if you need help with any of this though, because I know this is complicated.